question for you. Exactly how much bacon is appropriate for a fish fry? Just asking for a friend. Hey there, everybody. Welcome to episode number 518 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Why, yes, we will be talking about custom bacon, chip design, and this year's DVCon with Josh Rensch, 2023 DVCon Program Chair. A little later on, keeping with our protein theme, I check out how an AI system developed by a team of researchers at the University of California was able to generate brand new, never seen before proteins from scratch. Yeah. All right, so first up, let's welcome the man of the hour, Josh Rensch, to Fish Fry. Hi, Josh. Thank you so much for joining me.
It's awesome to be here.
Excellent. Okay, so Josh, for my audience who may not know, what is DVCon all about? And specifically, what kind of engineers should attend?
Well, it's DVCon, which is an acronym for Design Verification Conference. It has been going on for a long time. I don't know how long. I've been going to it for the last 13 years. And it's about, in chip design engineering, it's about, hey, how do we get better as chip designers and chip verification engineers and people that make the internet go? And who should come? Well, that's interesting. If you ask some of the sponsors, it's anybody who has money and can buy something. But for me, it is all about bringing people who want to get better in the engineering space, in the space that we talk about, which is the chip design. So that could be a manager, that could be program leader, it could be even an executive who wants to understand this technology better. I think it kind of runs the gambit. And the presentations also run the gambit. I mean, there's even papers or presentations, whatever way you want to call it, that are built around the space adjacent to the space of design verification. Like, how do we make our regression runs, aka the computers that run and check our designs and check our stuff, more efficient? And that's really not the full-fledged design verification, but it's an adjacent modality that makes the main modality of DVCon and the attendees better.
All right. So, Josh, you have a really exciting keynote at this year's DVCon. So tell me more about that.
Dirk, the CTO of Siemens, he's presenting what do farming, steel, and space have in common. It's about how all these different incongruent industries have similar roots of issues that are solved through digital and chip design and all that kind of avenue. How autonomous vehicles work in all those industries, how to better get crop yields, space exploration. I hope he can send me to space. I would love that, but I don't know if he will let me do that. I know I'm the TPC chair, and I may have to go and say, hey, can you get me into space? We'll see what happens.
I love it. All right. So, Josh, you have a panel this year called AI ML Algorithms Are Transforming Verification, Separating Hype from Reality. So tell me a little bit about the panelists who will be on this panel and what kind of challenges they'll be addressing.
Well, there is, looking at the panelists, CTOs and VPs of R&D and directors of applied learning for NVIDIA. There's going to be a breadth of different people on the panel, and it is about, there's different standards and different things around our industry, and how do we solve them? Like take ISO 26262, which is the chip safety standard for automobiles, and how AI can help get that done, because we really don't want accidents in cars from chip design. We really don't want that. And nobody's going to accept it. It's like, hey, sorry, we tried our best. Whoops. So the AI and machine learning, it's going to talk about how those help and what is real and what is not real. Meaning, like anything, people make things out of a panacea out of everything, right? Oh, if you do this, everything is going to be okay. And the panel is going to be about, hey, what is the real things and what is not? And engineers, we're really good at sniffing out what's real and what is not. So I'm looking forward to the panel and seeing how that goes.
So there's also another panel that piqued my interest called Systems Are Evolving. Is Verification Keeping Up? So tell me more about this panel as well.
I'm actually a verification engineer by training, which is all about making sure the chip we design is the correct design, meaning it doesn't have any problems. And this panel, from what I understand, is about how do we get verification better, right? The chips have gotten bigger, the chips have gotten more power, more robustness, more everything, just more. It's like America, more. And this panel is all about how verification can keep up with that. And if it can, if it can't, where it's going to break down, where it's not going to break down, that kind of thing.
Okay, so Josh, is there anything else you'd like to share about this year's DVCon, and what kind of deadlines should my audience keep in mind?
Well, the deadlines are already kind of passed. I think you can still register. You can't submit papers because that's done. That starts in August of 2022. But you can still register and you can still buy badge for it and still come. It's in San Jose. The other things I'm looking forward to, so as the TPC chair, I get to look at all the papers. That's kind of my purview. And there is a whole panel on machine learning, and there's a whole panel on RISC-V. RISC-V is getting more and more prevalent in this industry. And there's a whole session on RISC-V. Of course, there's sessions on UVM because that's been common since 2010. And as I said at the beginning, there is some sessions on how, there's some papers anyways, on how the adjacent modalities that affect our work, how to get better at those. And so I'm looking forward to those. Those are my three things. And not saying any of the other ones are bad. It's just when I look at the presentations and how we organize them, that is what I'm looking forward to the most.
Excellent. All right, Josh, it's time for your off-the-cuff question. Now, we were talking about food earlier, and you mentioned you make custom bacon. So I must ask you about that. How did you get started making custom bacon, and what kinds do you make?
So it started, a friend of mine left his smoker at my house, and I was in Costco, and Costco sells pork belly, and I bought it. And I didn't know what I was doing. I was just like, I'm going to try to smoke this and make bacon. Little did I know that there was more to that process than just setting it in a smoker. Now, the stuff I turned out to be basically pork belly jerky. It was good, but it was not really bacon. So then I learned. And so I make bacon. I make a bunch of different varieties. I play around with it a lot. When I say make bacon, I get the pork belly, I cure it for 10 days, and then I smoke it for 24 hours. And the current flavors that people really like, I make a black pepper bay leaf garlic, which is really good on BLTs, a bourbon maple, which is really good. It's breakfasty and can go with pancakes, whereas the black pepper bay leaf garlic does not go with pancakes. My wife will tell you she tried it and was like, ugh. So, but it's really good on BLTs. I've made cinnamon bacon. I've made Chinese chili pepper bacon. I've made regular bacon. That's easy. I kind of see what flavors I play with and I look at and I'm like, I wonder how that will be with bacon. But I've also made cottage bacon, which is bacon made from shoulder. And I made Canadian bacon. I'm air quoting for the audience, so it's bad radio, but air quoting Canadian bacon with a pork tenderloin. And that turned out really good as well. So I just make bacon for friends. So people say, hey, I want some bacon. They go and buy the ingredients or give me the money to go buy the ingredients. And I make bacon for people. And that's kind of been my jam for the last 10 years. So even before times, it wasn't like a hobby that I picked up during the aforementioned danger dark zone times of, I don't know if we're allowed to mention COVID, but that time, but I picked it up about 10 years ago and I've made a whole bunch of bacon.
So follow-up question, do you also make bacon jam?
Yes, I make a bourbon maple bacon jam. And its basis is Vidalia onions, and you basically cook those to like caramelize nothing, and then that's what transports the jam. I make those, smoke cheeses, and I smoke hard-boiled eggs. So yeah, I've been doing this for a while, and my wife doesn't like the bourbon maple bacon jam, but I do, and I've had it with peanut butter, and my wife is like, that is the grossest idea because she knows it's a basis of onions. And I'm like, it's not as bad as you think it is.
I love it. And I'm a huge bacon jam fan. So awesome. Well, Josh, I think that's all I have time for today. Thank you so much for joining me.
You're welcome. It's great to be here.
From custom bacon to AI-generated proteins, let's keep this meaty theme going. Okay, so get this. A team of scientists from the University of California, San Francisco, have developed an artificial intelligence system that is capable of generating artificial enzymes completely from scratch. And some of these enzymes work just as well as their natural counterparts, despite the fact that the artificially generated amino acid sequences in these enzymes diverge greatly from any natural protein. All right, so the key here is natural language processing. So this team from the University of California actually used a Salesforce research developed AI program called ProGen, which utilizes next token prediction to put together these amino acid sequences into artificial proteins. Now, before we go any further, protein design technology is not new by any means. But this team contends that their new technology will be able to energize this 50-year-old field of protein engineering by speeding up the development of new proteins. And that these new proteins could be used for almost anything from therapeutics to degrading plastic. James Frazier, PhD, professor of bioengineering and therapeutic sciences at the UCSF School of Pharmacy and an author of the associated research paper, says this about their new AI protein design technology. He says, "The artificial designs perform much better than designs that were inspired by the evolutionary process. The language model is learning aspects of evolution, but it's different than the normal evolutionary process. We now have the ability to tune the generation of these properties for special effects. For example, an enzyme that's incredibly thermostable, or likes acidic environments, or won't interact with other proteins." So, how do they do it? Well, first, to create the model, they fed amino acid sequences of 280 million different proteins of all kinds into the machine learning model and let it digest that information for a couple of weeks. The model then churned out 1 million sequences. But this research team only chose 100 to test based on how naturalistic the AI protein's underlying amino acid grammar and semantics were, and how closely they resembled the sequences of natural proteins. Within the first batch of these proteins, which were screened in vitro by Tierra Biosciences, this team made 5 artificial proteins to test in cells, and then compared their activity to an enzyme found in the whites of chicken eggs, known as white lysozyme, or Huel. So 2 of these artificial enzymes were able to break down the cell walls of bacteria with activity comparable to Huel, yet their sequences were only about 18% identical to one another. And the sequences were also about 90% and 70% identical to any known protein. Okay, it's important to point out that only a single mutation in a natural protein can make it stop working. But in a separate round of screening, this team found that the AI-generated enzymes showed activity even when as little as 31% of their sequence resembled any known natural protein. And even cooler, this AI system was also able to learn how the enzymes should be shaped from only studying the raw sequence data. Although these sequences were like nothing seen before, when measured with X-ray crystallography, the atomic structures of these artificial proteins look just like they should. Ali Mandani, the paper's first author, sums up this research like this. The capability to generate functional proteins from scratch out of the box demonstrates that we are entering into a new era of protein design. This is a versatile new tool available to protein engineers, and we're looking forward to seeing the therapeutic applications. Me too. Super cool, right? So if you want even more information about this protein developed by AI study, I've included a couple links in the YouTube description for this week's episode and on the associated page on EE Journal as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, sure, I completely understand. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and a selection of fish fry episodes as well. And you can subscribe to our EE Journal YouTube channel as well. I'm just saying. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Fryin' page. Thank you everyone for tuning in. If you know of any cool new technology, or heck, you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com. Or post a comment on our forums on EE Journal. For the week of February 10th, 2023, I'm Amelia Dalton, and you've been fried.